everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the different types of samplings that should be done in statistics we are going to be see now. So before going to see that, so normally the data is going to be classified into different types. So I covered some of the topics in the previous videos. So let it be like discrete and then continuous. So again, this discrete data is going to be classified in further types like nominal, ordinal, ratio scale, and then interval level. So normally the data will be will be come from the different sources like internal and external sources. So that data is going to be categorized in the form of discrete as well as in the form of continuous. So discrete means again this discrete should be of two types like nominal one and then ordinal one. So how are going to be characterize this nominal data and ordinal data, and continuous means how it should be categorized in the form of interval and then ratio scale. So let me explain some of the examples how this data is going to be classified for that. So nominals, if I'm going to be considered, then the assignment of numbers for classification purposes, that should be considered as a discrete data like categorical data. So where should be like sex, blood group and all. So classification of the things should be comes under the discrete one. Again, that should be the subcategory of nominal data. So blood group, if I'm going to be considered, so it should be A plus, O minus, B minus, and then B plus, like this, right? So the blood group is going to be classified into different categories. So what we call it as the categorical data. So that data will be treated as an example of nominal data. And similarly, if I'm going to be considered the discrete one, so again this discrete data will be of the second type, what we called as the ordinal data. So ordinal means that, so here it should be quantitative values, so going to provide the classifications according to the order or magnitude, like SC status, VS, like that. So ordinal one, so where this value is going to be an quantitative one, so it should also provide a classification according to the order. Let it be like some run winners of the games like 1, 2, 3 and alphabetical orders, and then some particular order is going to maintain. So this kind of data will comes under this ordinal one. Like magnitude, what we can able to say that, so according to that data should be treated as the ordinal one. Similarly, if one comes to continuous one, so here the continuous will be of again two types like interval and ratio scale. So again this interval means where the classifications should be done according to the width of the interval, quality, and then subdivision sensibility, like that should be interval. So like if I'm going to take some based on the time the data which is going to be changes, so that should be normally treated as a continuous one. So what is again this interval and what should be again this ratio? So the interval means it should be of temperature, so where the temperature, so particular time, so from 9 a.m. what should be the temperature, and 10 p.m. So again 10 a.m. What should be the temperature, and then 11 a.m. what should be that this temperature is going on changes according to this time, so with respect to time. So this thing should be treated as the interval level. And what should be this absolute values, if I'm going to consider, then that thing should be treated as the ratio scale. So height of the person and then weight, which is going to be changed based on the interval, so that should be treated as the ratio one. So the data should be of different types of discrete and continuous. Again this discrete is going to be like ordinal one and then nominal, and then continuous means interval and ratio scale. So based on the type of the data, so normally you are going to be perform some of the statistical tests. How are going to be do that? So for that Once I'm going to consider types of the data, like qualitative, and then again this quantitative, where you can able to perform some nominal distribution. uh, okay, and then column wise, another column I'm going to be take it here is that kinds of comparison distribution. So here the comparison are two test groups, and then the comparison of valid test more than two groups I'm going to be split it. So again, so for this two samples, what kind of tests I can able to perform on the qualitative data, like a chi-square test and just test. And for this norm quantitative data, so normally you can able to perform t-test and then test with the sample where should be greater than 30, and Wilson, and then many Whitney tests, chi-square tests. So these are the some of the other types of tests we can able to perform apart from the normal distribution. So similarly, if I'm going to do that on one sample, so I can simply perform sign test, and then here it should be one sample test and sign one sample test. And then next one, so if I'm going to be perform independent one, so at that time I can able to perform chi-square test, and then one-way analysis, and then Wilson test critical. This should be another kind of the test what can able to perform on it. If it should be greater than one, then I can able to perform coherence Q test and two-way analysis of variation, and then freedom test. Like this, I can able to perform some of the different types of tests in statistics based on the type of data. Some of these levels of measurements should be also be different, should be of different slides, like nominal, ordinal, interval, and ratio scale. So nominal means we're unable to treat the categorical data, and ordinal means the category some based on some order. If I'm going to consider, then it should be ordinal one, and interval is the under kind of the thing where can able to be perform, so where they can able to make the differences but no starting point here. And ratio scale is another kind of the thing, it should make the differences between differences and natural starting point. So some of the levels of measurement, like for the first thing should be nominal, ordinal, and interval, and then ratio scale. Okay, so nominal level of measurement. So nominal level of measurements means where the it should characterize the data that consists of names, labels, and categories only, and then the data cannot be arranged in the ordering scheme such as lower to high, and then survey responses like yes or no, undecided, like this. So the nominal level of measurement means so where the data is going to be characterized based on the names, labels, and categories only. Uh, Let it be where the data cannot be arranged in ordering schemes such as low to high, though that thing should be treated as the nominal level of measurement. So example like survey responses is the thing like yes or no and undecided, like this. And next one is ordinal level of measurement. So here it involves the data that may be arranged in some order, so that should but the differences between the data values either cannot be determined or it should be meaningless. Okay, so the ordinal level of measurement means so here the data may be arranged in some particular order, like course grades, A plus, A, B, C, D, like this. So where these grades are going to be arranged in particular order. So suppose winners, runner, like this, and some alphabetical orders. So like this I can able to differentiate the data where the data is going to be organized in different orders. So like differences between the data values either that cannot be determined or meaningless. So this and all will be considered as an ordinal level of measurement. And next one is interval level of measurement. So interval like it should be similar to the ordinal level, and with the with the additional property that the differences between any two data values it should be meaningful. So however there should not be no 0 point here, so where none of the quantity is going to be present. So interval level means, so in particular interval to interval, suppose some 1990 to 91, so what kind of data it is, and for any kind of application, and then 91 to 92, so how much the data it is, like this. So based on the data what I'm going to get, and that should be the interval level of measurement. Okay, so this should be also similar to the ordinal level, and so with the additional property is going to be there in interval level of measurements. So that it means that is that the differences between the two data values, and however there should not be any non-zero starting point. And ratio level of measurement, so this is the another kind of level of measurement here. So here the interval level modified should be include the natural zero starting point. So previous one I should not include this 0 point. So here I include the zero starting point where the zero indicates the none of the quantity, and for the values at the at this level, the differences and ratios are going to be meaningful. So example, the price of college textbooks, which should be represents no cost. So this should be one of the example of this ratio level measurement. So in this ratio level measurement, so it should be similar to the interval level. So which where the slight modification is done, so which is going to be include some zero starting point. So where the zero is going to be indicates this quantity, none of the quantity here. So example of price of college textbooks, like this. And next one is, so what are the some of the misuses that should be happen in the statistics. So for this, so bad samples. So if I'm going to be collect the bad samples, the data what I'm going to be done through statistics, that should be entirely wrong. And next one is that small samples. So in order to perform this statistics, so if I'm going to collect only limited number of samples, so that should be not that much make efficient one for any kind of application. And misleading graphs, so the graphs which is not going to be represented properly due to these bad samples and then small samples, it is not that much effective for representing the visualization of the data also. And pictograph, so pictograph also something may be different due to this, and disordered percentages, and then loaded questions and order of the questions. So these are the some of the misuse of the statistics, which should be makes not that much effective for visualization of any kind of application. And then refusals is also some of this one of the issue of statistics. And correlation and causality and self-interested study and precise numbers, partial pictures, and deliberate distortions. So these are the some of the misuses of the statistics where we are able to deliberate some distortions. So that should be also one of the problem that may becomes while using in statistics. And partial pictures, so incomplete pictures also not that much easy and not that much effective of representing this. And precise numbers and self-interest study and correlation and causality, like this we are going to have some of the uh, issues that maybe comes in statistics. So very dangerous thing is going to be this bad samples, and that should be able to get major reflect on this statistic visualization of the data. So apart from this also I'm going to have some other like small samples, misleading graphs, and pictographs also not that much effective for data effect visualization. And normally we are going to see some of the terms that may becomes reflected on sampling should be replication and sampling size. So what should be the replication here? So replication is nothing but an experiments where there are enough subjects to recognize the differences in different treatments. So that should be the replication here. So replication means repetition of an experiment. So where they're going to be have enough subjects to recognize the differences in the different treatments. So that should be considered as a data replication. And then sampling size, so sample size, it should be a large enough to see the true nature of any effects, and going to obtain the sample size using an appropriate method such as one based on randomness. Okay, so the sampling size is this thing, is the value, so that should be large enough to see that the true nature of any effects, and then which is going to be obtained that sample is using the appropriate methods such as one based on randomness. So these are the two types of the things that going to be remembered for implementing this sampling here. And then what should be the random sample here? So random sample means it should be a member of the population that is going to be selected in such a way that where each individual member is going to be have equal chance of being selected. So the random select sample is nothing but it should be a members of the population, so which are going to be selected in such a way that each individual member is going to be have equal chance of being selected. And next one is simple random sample. So this one should be present should be on based on the size. So where the subjects should be selected in such a way that possible of the sample size n is going to be have same chance of being chosen. So this should be the simple random sample. So the simple random sample, these are the objects or subjects it may be. So that should be selected in such a way that each and every possible sample of the sample size and has the same chance of being chosen. So this should be the simple random sample. So here I'm going to explain some of the different types of samplings. What I can should be that random sampling. So random sampling means it should be a selection such that each has an equal chance of being selected. So among this so much of data, so randomly I'm going to pick up some particular portion of this. So this is one of this data I'm going to sample, and that particular portion of this will be considered as a random sample. Okay, so these are the selections such that each one is going to have equal chance of being selected. Selecting some particular portion of this entire data should be treated as a random sample. And next one is the systematic sampling. So systematic sampling means so where among this data here I'm going to be selected only the particular selected data here. So I'm going to have some data like this. I'm going to be selected with the difference of 2. So that thing should be treated as a systematic sampling. So we should be able to select some starting point, and then we have to be select each every kth element in the population. Okay, so among this population, so if I'm going to be systematically selecting the data will be treated as a systematic sampling. So what is here? So here the kth element may be 3. So with a difference of 2 I'm considering. So 3 plus 3 how much? 6, and then 6 plus 3 if I'm going to have another one 9 I'm going to be selected. And next one is convenient sampling. So using these results that should be easy to get ready. So that should be convenient sampling. So normally this sampling should be best one. So based on the convenience we are going to be extract the results from the population. And next one is stratified sampling. So stratified sampling means so here the population is going to be divided into subgroups. So where each group is going to be have the similar characteristics. That's where the sample may be drawn from the each subgroup. Let's suppose here this is the population I'm having, and within this population I'm having some dots, and then I'm going to another kind of data where I represent and another thing. star is another kind of data, and where this is the another thing of population, right? So from this population where I'm going to be separate the data based on the characteristics into groups, like so one should be group 1, so in group 1, and then I'm going to consider as group 2 and another group 3. So from this I'm going to extract the data of all the similar characteristics, so that should be plus here. And similarly I'm going to be extract the data which is going to be have the similar characteristics, so that should be the dot. And similarly from this I can able to extract star. So like this I can able to segregate the data based on the characteristics, so that should be treated as the stratified sampling. Okay, so among this population, so even these are the items, so from these items I can able to extract all the girls should be one side and all the boys should be gender is going to be separated here. Okay, so based on the gender, but this each and every item is going to have different types of characteristics, so the main characteristic should be men, so that should be separated, and this should be women. And next one is that cluster sampling, so this should be another kind of the thing. So here we have to be divide the population into different sections or the clusters, so like where we can able to randomly select some of these clusters, or we can able to choose all the members from the selected clusters also. Suppose the population is there, so here I can able to select the clusters data, so based on the characteristics, and this should be one cluster and cluster C1, and this should be another cluster. From among this data I'm going to be grouped as odd as the one group and then even as the another group here, so that what will happen, all the odd data like 1 and 3 5 7 9 13, like this, all the data will come, and 2 4 6 8 10 12 and 14, so all the even data, so I can able to treat it as the one cluster. Okay, so among this population what I'm going to be do from this population based on the characteristic I'm going to be separate the clusters here, so one should be of even cluster and there should be of odd cluster. So how it should be, I can able to be segregate in as the odd and even, like this. And next one is what are the different types of samplings we're having, like this. So from this sampling one should be random sampling, systematic sampling, convenience, stratified, and then cluster. So random sampling is the one of the method, and then where you can able to randomly select the data from among the population, so that thing should be treated as the random sampling. And next one is systematic sampling. So systematic sampling means, so where based on some particular order we're going to be systematically selected the elements, like first one and then third one and then fourth one, like this. And next one is convenience sampling. So convenience is the thing, so where according to our convenience we can able to extract the data based on the characteristics. And next one is stratified sampling. So stratified means, so where you can able to be segregate the data based on the groups here, group 1 and then group 2, so like this we're going to be segregate the data, that should be stratified sampling. And cluster sampling, so based on the data characteristics we're going to be group the data of one cluster, cluster 2 and then cluster 3, like this. So these are the some of the methods that are available for representing this sampling here. So once the sampling is done, I'm going to have two types of errors that may be present here. So one is a sampling error, another one is non-sampling error. So sampling error means it should be a difference between the small sample result and then true population results, such that where the error results are from the chance of sample fluctuations. And non-sampling error means so the sampling data that should be incorrectly corrected, recorded and analyzed. Okay, so that should be non-sampling error. So sampling error means there should be a difference between the sample result and the true population result. So the error that comes while drawing the sample from the true population result. Okay, so there may be a chance of getting this results of due to some fluctuation. That should be sampling error. Non-sampling error means that so it should be a sample data, so that should be incorrectly collected and then where you can able to incorrectly recorded and then analyzed. Okay, such as by selecting the biased sample and then using some defective instrument and then copying the data incorrectly like this. So this and all will be treated as the non-sampling data. So non-sampling means we're unable to extract the uh, data not properly collecting, not properly analyzed, and then we're unable to make the defective sampling here, and where can able to copy the data incorrectly. So these are the some of the different types of samplings where you can able to see this. So normally the data may be of different types like discrete and continuous. So again this one should be of different types like nominal, ordinal and interval ratio scale, and where you can able to perform some of the statistical tests based on the types of data like chi-square test, z test, t test. And levels of measurement will be of different types like nominal, ordinal, interval and ratio scale. So nominal means we are able to consider only categories only, and ordinal means we are able to extract only the data based on the order, and the interval should be of differences but no starting point. And here the ratio means here we have to be consider the differences but we are going to do the natural starting point. And nominal means so here the data should be arranged, not going to be arranged in ordering one, so that thing should be treated as the nominal one. And ordinal means where the data is going to be arranged in different orders, so either in form of ascending or descending order where so but order is going to be maintained, so that should be treated as ordinal level of measurement. And interval level of measurement means so it should be also similar to the ordinal one, so but so with the additional property what is going to be have is that so it should be a difference between the data should be meaningful but no zero starting point is going to be considered here. And ratio level measurement, so it should be of another thing, so where you can able to consider the zero starting point. So some of the chances of getting the misuse statistics should be that bad samples, small samples, and misleading graphs, pictographs, and then loaded in order of the questions, and then precise number, partial pictures like this. And some when it comes to the sampling, so here I'm going to be explain what should be replication. So that should be repetition of experiments. We are going to go have enough subject to recognize the differences in different treatments, and sample size it is going to be a large enough to see that it should be for appropriate methods based on the randomness. That should be the sample size. And random sample means so here it should be members of the population that is going to be selected randomly of equal chance of being selecting. And simple random sampling, so based on the size we are going to be extracting the data, that should be simple random sample. So some of the types may be random sampling, systematic sampling, and convenient sampling, and then stratified sampling like this, and cluster sampling. So these are the some of the methods that are available for implementing the sampling. So once the sampling is done, there should be a chance of getting errors, so that one should be treated as a sampling error and then non-sampling error. So sampling error means so that should be the differences between the sample result and the true population result. That means so whenever the differences that maybe comes drawn from the sample result and true population results, so that errors is going to have some little bit fluctuations. So for the fluctuations will have to be considered as the sampling error. Non-sampling error means so it should be data which is going to be drawn incorrectly or incorrectly recorded, and then it should be incorrectly analyzed, so that thing should be treated as the defective instrument through, or one can while copying this, so we can able to get some of the errors, so that thing should be treated as the non-sampling error.
Like, share and subscribe. Hit the bell icon for more updates.